I'm Max, and every week I'm reading from this 2025 AI Engineer reading list. This was week 3, and I took a look at Meta's LLaMA papers. Meta's first LLaMA paper proved that you could still create a really powerful language model training only on public data. Their core idea was that if you train a smaller model on more data, you'll end up getting a efficiency boost. And this contrasts with OpenAI and what they did, where they thought that just throwing more parameters and creating bigger models would increase performance. We saw that LLaMA's first model, a 13 billion parameter one just called LLaMA, actually could outperform GPT 3.5, a much bigger model, in a bunch of benchmarks. And this is great because it being 13 billion parameters, that's small enough to actually run on a consumer GPU, which makes it much more accessible for everyone. They used the same sentence piece tokenizer that Google used in their Gemini paper that I read last week. And they had 2 special cases they called out. The first is that for numbers, they split all numbers into their individual digits, and they had a fallback to go back to bytecode if there was any UTF characters that they didn't actually understand. They also calculated how much emissions were produced in the training of this model, and it came out to about 1,000 tons of CO2, roughly equivalent to 216 passenger cars in the US, how much they produce in a year. In the LLaMA 2 paper, they released a 70 billion parameter model. They increased the training dataset size by 40%. They doubled the context window, and they started implementing grouped query attention for better speed. For the supervised fine-tuning, they actually found that quality was a lot more important than quantity, and their final data set here was just 25,000 annotated prompts. They had a very long section on safety that mirrored a lot of the insights from Google and Anthropic's papers, but the one big insight was that feeding a bunch of safety training data into the reinforcement learning for human feedback section doesn't actually reduce the helpfulness of the model. The last paper I read was the LLaMA 3 paper. Massive model, 405 billion parameters trained on 15 trillion tokens. Performance, it's about on par with GPT-4. Model architecture, they used a new tokenizer with a 128K vocabulary. For training, they go really in depth with all the infrastructure they used. So they used 16,000 H100 GPUs. For me, the interesting thing was this table of root cause for all the different hardware failures, and they talk about their effective training time, which was 90%, a lot less than Google Gemini's 97%. So it's interesting to actually have those numbers and compare the 2 trainings. The last thing that they focused on was inference, ways to quantize the data, which basically means round some of the floating point numbers that you have, or do pipeline parallelism, which means having parts of the model run on different GPUs. Next week, I will be looking at the DeepSeek papers, so I'm excited for that. Tune in. See you guys then.